here's the inverse of a second degree function. So let's take, for example, the function y equals x squared minus 2x plus 1. So before you can do anything here, before you can replace the x's and the y's, switch them around, you have to put this in function form. So let me remind you what function form looks like. Function form looks like this. F of x is equal to a x minus h squared plus k. And the reason you want to switch it into this form over here rather than keep it in the general form is because in the function form, there's only one x and one y on both sides, right? We have y equals, I'm just going to rewrite this, x minus h squared plus k. So we only have one x and one y on either side. Whereas here in general form, we have one y, but two x's, one x squared and one x to the power of 1. And that would complicate our lives if we kept it this way. So what I'm going to do is turn this general form into standard form. And the way we do that is first by finding the value of h. And we know that h is equal to minus b over 2a. And that would be 2 divided by 2, so that's 1. So our a, let me remind you, a is over here, b is over here, and c is over here. And to find the value of k now, we replace the value of h into our general function here where in the place of x, and we solve for y. So we have k is equal to 1 squared minus 2 times 1 plus 1. And that gives us 1 minus 2 plus 1, and that's 0. So finally, we can rewrite our function as y equals a in the standard form is the same as a in the general form, so 1 bracket x. Now my h was 1, so it's going to be minus 1 squared, and k is 0, so I'm not going to write plus 0 because I don't need to. Great, so now that I've got this in this form here, let's inverse it. So in yellow, I'm going to write the inverse of this. So I write x in the place of y, and I write y in the place of x, like this, y minus 1 squared. Now I get rid of my square roots because what I'm trying to do is isolate my y. I get rid of my square by square rooting both sides. I get the square root of x equals, and then if I square root this side, it cancels with the square, so I have y minus 1. And now I bring the minus 1 to the other side, and I get square root of x plus 1 equals y. And I'm just going to rewrite this with y on the left-hand side. I get y equals the square root of x plus 1. And this is it. I've isolated my y, so this is actually just the inverse of this up here. Notice that the inverse of a second degree function is a square root, and that kind of makes sense because when we're doing the inverse of two graphs of two functions, we're finding opposite functions. And the opposite of a square is a square root. So this here is how we find the inverse of a second degree function. And I will show you in the next video how to do the inverse of a square root function, which of course you can imagine will give you a second degree function.